So say we have a particle of rest mass m naught, and it has a momentum p, which is 3/4 m, right? It's really 3/4 m times c. So the particle is moving, and it decays into particles of light. So one travels one way and one travels the other. So it decays. Here's the particle, it decays into two particles of light. Let's find the energy of the two particles of light. So what we have is a particle whose two momentum is some E and P. We know what P is, so we don't know what the E is because the particle is moving. So E is not just m naught. We know a P that's been given, 3/4 m, so we construct that two momentum. But we need to find what E is. Of course, we know that E squared equals P squared plus m squared. And so in this case, we have that this is, so E is the square root of P squared, and so that's 9m, sorry, so this is m naught, so this is 3/4 m naught, this is 9m naught squared over 16 plus m naught squared, and that's, this is 16 over 16, that's 25 over 16. The square root of 25 over 16 is 5/4 m naught. So that's the energy. And so we can say that the two momentum of this particle prior to decay is 5/4 m naught, 3/4 m naught, and if we put c in there, it's 5/4 m naught c squared, 3/4 m naught c. And now this breaks up into two particles. So we have, let's break this up into two light particles with energy E1 and momentum P1 plus energy E2 and momentum, well, let's call it P2, but we know that this has to be, this is a positive value, this has to be negative. And there's a relationship between the energies and the momenta, which is E equals P, or that's the relationship between energy and momentum. There's really a factor of C here. So the momentum is really E over C, and so we can replace these just with E. So let's replace this with E1, it's really E1 over C, and this with E2, it's really E2 over C. And so our relationships become 5/4. All right, so the sum of the two four momenta of the light particles adds up to the two momenta of the particle. So 5/4 m naught is equal to E1 plus E2, and 3/4 m naught must equal to E1 minus E2. And so we can just add these two equations, right? So the E2 cancels here. We'll get 5/4 and 3/4. That's 8/4, which is 2 m naught is equal to 2 E1. So the particle, so one photon has energy m naught. It's really m naught c squared, and the other one has energy 5/4 m naught minus E1, which is m naught. So 5/4 minus 4/4, that's 1/4. That's really m naught, 1/4 m naught c squared.